Next one we're going to talk about is Sven and Arrhenius. So Sven Arrhenius was a Nobel Prize winning Swedish scientist, originally a physicist, but often referred to as a chemist and one of the founders of the science of physics chemistry. He received the Nobel Prize for Chemistry in 1903, becoming the first Swedish Nobel laureate, and in 1905 became director of the Nobel Institute, where he remained until his death. So his lasting contribution to science are exemplified and memorizable by the Arrhenius equation. Arrhenius' definition of an exit lunar crater the mountain of Arrhenius Field, and the Arrhenius Labs at Sherlock Holmes University, all named after him. He was the first to use basic principles of physical chemistry to calculate estimates of the extent to which increases in atmospheric carbon dioxide increase Earth's surface temperature through the greenhouse effect, leading him to conclude that human-caused carbon dioxide emissions are large enough to cause global warming. Next, we're going to talk about is calendar. So, in 1989, John Tyndall in England identified water vapor and carbon dioxide was having the capacity to trap heat in the atmosphere and being most effective in offsetting nighttime cooling. The first scientific statement of the role of GHGs in the atmosphere was made by Sven Arrhenius in Sweden. We just mentioned, in 1896 he calculated that reducing the carbon dioxide concentration in the atmosphere by half would lower the air temperature by 4 to 5 degrees Celsius. The amplifying effect of ice albedo feedback in high latitudes would then permit ice age conditions to develop. Conversely, increasing carbon dioxide would raise temperature globally. Arrhenius also recognized that since warmer air can hold more water vapor, there would be a positive feedback effect that would further raise air temperature, since more water vapor would lead to more trapping of infrared radiation. Although water vapor accounts for about half of the natural greenhouse effect, it is carbon dioxide that is the controlling factor, since it remains in the atmosphere for long intervals, whereas water vapor is constantly recycled. Arrhenius estimated that a doubling of the carbon dioxide concentration would rise global temperature by 5 to 6 degrees Celsius, close to modern estimates. This idea was dismissed for 50 years, although in 1931 an American physicist, Hubert, got results similar to Arrhenius in a little newspaper. In Britain, Guy Stewart calendar in 1938 calculated that atmospheric carbon dioxide concentration had increased by 10% since the 19th century, and that this would explain the observed warming since the 1980s. He also estimated that a future doubling could rise temperature by 2 degrees Celsius. Guy Stewart calendar was an English steam engineer and inventor. His mainly distribution to knowledge was developing the theory that linked rising carbon dioxide concentration in the atmosphere of global temperature. This theory, earlier proposed by Sven Arrhenius, has been called the calendar effect. Calendar thought this warming would be beneficial, delaying a return of deadly glaciers. So Gilbert plus carbon dioxide research. So, using a better atmospheric model of infrared radiation absorption and computers, so this American physicist Plus calculated that doubling carbon dioxide would raise temperatures by 3 to 4 degrees. So Gilbert Plus was a Canadian physicist who in the 1950s made predictions about the increase in global atmospheric carbon dioxide levels in the 20th century and its effect on the average temperature of the planet that closely matched measurement reported half a century later. So Plass worked most of his life as a physicist in the United States. He graduated from Harvard University from 1941 and earned a PhD in physics from Princeton University in 1947. And then later he joined the staff at the Aero Division of Ford Motor Company in 1960. He became manager of the research lab at Ford's Theoretical Physics Department and a consulting editor of the journal Infrared Physics, now called Infrared Physics and Technology. In 1963, he accepted a position as the first professor of atmospheric and space science at Southwest Center of Advanced Study, now the University of Texas at Arlington, where he remained for 5 years. And then he go to the University AT&T XMM. So he told Time magazine of his work of the effects of carbon dioxide from industrial sources as a greenhouse gas and the potential implications of an increased concentration of carbon dioxide in the atmosphere for global warming. So his research is mainly focused on carbon dioxide research that you can read from here. And next we're going to talk about is Hans Suzy and Roger Revelle. So those are two important figures that you might have to remember a little bit more. So in 1957, Hans Suzy and Roger Revelle, that they did was drew attention to increasing levels of carbon dioxide as did Callender in 1958. Beginning in 1957, Charles Killing began to measure carbon dioxide in the atmosphere every 10 seconds on the top of the volcano Mauna Loa in Hawaii. He isolated a location in the Central Pacific, provided an ideal benchmark of the global signature. So Suzy's most recent research was focused on the distribution of carbon-14 and tritium in the oceans and atmosphere on basis of radiocarbon analysis of annual growth rates of trees. He contributed to the calibration of the radiocarbon dating scale and the study of the magnitude of the dilution of atmospheric radiocarbon by carbon dioxide from fossil fuels burned since the Industrial Revolution. This diffusion is known as the Suzy effect. And Roger Revelle was a scientist and a scholar who is instrumental in the informative years of University of California, San Diego, and was among the early scientists in studying anthropogenic global warming as well as movement of Earth's tectonic plates. So the UC San Diego First College was named Revelle College in his honor. And Revelle was deeply involved in the growth of oceanography in the United States and internationally after World War II. Working for the Navy in the late 1940s, he helped to determine which projects gained funding, and he promoted the idea that the Navy ought to support basic research instead of only trying to build new technology. So as Scripps, he launched several major long-range expeditions in 1950, including the Mid-Pac, Trans-Pac with Canada and Japan, and the other research traversing a different part of the Pacific Ocean. And he and other scientists at Scripps Institution of Oceanography helped the U.S. government to plan nuclear weapon tests in the hope that oceanographer might take use of the data. So, and he did a lot of things that he's instrumental in creating the International Geographic Year in 1958 and founding chairman of the first Committee of Climate Change and the Ocean under the Scientific Committee on Ocean Research and the International Oceanic Commission during planning the IGY under Reville's directionship. SIO participated in and later became the principal center for the atmospheric carbon dioxide program. In July 1956, Charles David Killing joined the SIO staff to head the program and began measurements of atmospheric carbon dioxide at the Mauna Loa Observatory on Mauna Loa, Hawaii, and in Antarctica. So, here the Reville and Susie's describe the buffer factor as known as the Reville factor, which is a resistance to atmospheric carbon dioxide being absorbed by the ocean surface layer posed by carbonate chemistry. Essentially, in order to enter the ocean, carbon dioxide gas has to partition into one of the components of carbon dioxide, acid carbonate ion, bicarbonate ion, or protonated carbonate acid, and the product produced of these many chemical dissociation constants factors into a kind of back pressure that limits how fast the carbon dioxide can enter the surface. Ocean geology, geochemistry, atmospheric chemistry, ocean chemistry. This amounted to one of the earliest examples of integrated assessment, which 50 years later became an entire branch of global warming science. So Charles David Killing was an American scientist whose recording of carbon dioxide at the Mauna Loa Observatory first alerted the world to the possibility of anthropogenic contribution of the greenhouse effect and global warming. The Killing curve measures the progressive building up of carbon dioxide, a greenhouse gas, in the atmosphere. Killing soon declared a steady increase superposed of annual due to a seasonal change plant biomass. The Mauna Loa record in those and numerous other locations around the world contribute to maintain in the 1970s and 1880s. Attention turned to other greenhouse gas, methane, nitrous oxide, ozone, and chlorofluorocarbon. So Ralph Killing is David Killing's son. That he continued his work, but more he did a lot extra work that we're going to go through a little bit quick. So he developed his first scientific instrument, a light gauge interferometer for the accurate measurement of atmospheric oxygen as part of his PhD research. By October October 25, 1986, Cooling had developed a working prototype, a stainless steel box about 7 feet tall with a glass front. Inside the box, light beam shines through the gas molecules of air samples. Cooling's inferior